Yeah, good evening, everyone. I, Rohit Singh, on behalf of Society for Data Science BIT Machra, welcomes you all for this session. And I have joined with my fellow colleague, Miss Ravi. And so today in our session, I have Mr. Ludovico, who is the developer of Surrogates.jl library, and he is a proficient in high-level mathematical machinery. And as we know that Mr. Ludovico is an expert at the intersection of the mathematics, simulation process, and statistics. Being capable of writing code in several programming languages, he has also won HackTheAlps along with his team. So, Mr. Ludovico, who was the GSOC participant during May 2022, August 2020 at the Julia community. With the GSOC, he has also achieved many titles in his life till now. So, I would like to list some of them. So, currently, he is doing his master's thesis at Volvo Group, where his work is to develop two-stage object detection models using PyTorch and TensorFlow to detect interesting events from onboard camera in the vehicles. And he is also deploying the models on Qualcomm chips for testing purposes and other things like currently in the past he was a research engineer intern at the Alan Turing Institute during September 2020 to December 2020, where he has done research on new multi-objective optimization techniques algorithms with the focus on fairness for machine learning. And he had also created a POF for a domain specific language written in Julia to express epidemiology models concisely. And he had also enhanced MLJ Turing.jl library by adding new hyperparameter algorithms. And on Feb 2020, he had been selected among other 30 students of his college to work as a team to leverage big data analysis. The aim was to extract knowledge about customers of a car insurance company to score the customer's driving style and to perform clustering analysis. And during November 2019 to May 2020, he was machine learning engineer intern at the Clearbox AI Solutions, where he has worked on adversarial attacks with a focus on computer vision. So, like his task was to find minimal perturbations to deceive trained machine learning or neural network models, and it was achieved using optimization techniques in combination with surrogates models. So it was all about Mr. Ludovico, and now he will tell about more about his journey and how you can continue for GSOC. So let's continue.
Yeah, thanks for the long introduction. I'm glad to be here. Yeah, as Rohit said, I've participated in the Google Summer of Code last year, and it was really a great experience that I strongly encourage you to try and achieve. For this reason, I've prepared some slides to guide you a bit in the process and especially around the Julia community. So let me share my screen now. Let's see. Okay. I think you can see the screen now. So here we go. So I did my Julia season of contribution and Google Summer of Code with Julia. Julia is a relatively new programming language that focuses on scientific computing and machine learning in general. In these 2 summers, I have developed Surrogates.jl, which is a library under the scientific machine learning community that deals with approximating techniques. So before moving on, a few information about what I did after these 2 experiences. I've interned at Clearbox.ai and at the Alan Turing Institute, working on computer vision and fairness for machine learning. Then I'm currently interning at Volvo Cars as a machine learning engineer, working on computer vision model for autonomous driving. And then I will be moving to CERN in July, and from July to December, I will be doing some scientific computing there. In the middle of all this, I'm also on mentor cruise. That is, I mentor new students or working professional that want to employ their technical skills in the open source community and in general in the machine learning and in data science communities. Okay, so this was just to show you what you can do after you did your Google Summer of Code, and I believe that all this internship that I managed to secure were thanks to my work experience with Julia. Okay. Then how does someone get into Google Summer of Code? Well, first of all, if you want to contribute to a project, the first thing that you need to do is learn how to use a library or the tool that you actually want to work on. Then after you learn the tool, you need to get to know the community and to understand what's missing. So here is important that you understand how the library, how the models work, so you can understand what's missing. And then you ask the community if what you think that it's missing is important to being added. And then so you look for easy open issues on the GitHub page of that specific repository and start working on them. Here is crucial that you start working early on these easy issues so you can secure them and you are the only one working on them in order to avoid maybe that other people that are working on your same open issues. To do this, you open a pull request on GitHub and you commit often to your pull request. That way you can, first of all, showcase that you are actually working and not just talking. And secondly, you can also get some help from the community. So, and this is very, very important. It's the bread and butter of the Google Summer of Code experience. You're not just coding alone and pushing code yourself. You are actually working in a diverse community of people. And so one of the greatest learning experience is to learn how to code with others and share your code and share your ideas and discuss your implementation details. So this is very important. You need to showcase your ability to work. You need to showcase that you know how to work well with others. Okay. Here now I will give a brief introduction, given that this is a data science, community. I will give a brief introduction to surrogates. So the idea is that we have some very expensive function, call it f, and we want to approximate this very expensive function because maybe we don't know its true analytical form. Maybe it's too expensive to even compute. So we want to approximate it. Usually this kind of function come from, probably they are solutions of differential equations, stochastic differential equations, system of partial differential equations, and so on. So to get to know this function, it's usually, you need to usually rely on heavy linear algebra tools that, as I said, are very, very expensive. Then how can we approximate a function? Well, there are 3 steps. First of all, we need to sample. We need to decide on which points we want to evaluate our true functions on. Then we need to model the function, that is trying to fit some model to these data points. And maybe this could be as simple as a linear regression, polynomial regression, or maybe like a neural network. It's not important, the tool, but the idea. So modeling. And after that, we are not only interested in modeling the function, this black box function, we are also interested in optimizing this function. That is, in this case, when I say optimizing, I say finding, for example, the minimum, the maximum, or local minimum. And so this pipeline is done already in Julia, and it's what Surrogate is about. Let's see. Let's start from the sampling. So here we have a simple example. On the right, we see the code in Julia, quite straightforward to understand. Using surrogates is similar to Python importing. So like from NumPy import something. Then we define LB, UB, which stands for lower bound and upper bound. And then say, I want to get a sample, let's say 50 samples between 0.0, that is the lower bound, and 14, say, that is the upper bound. And how do I want to sample this space, which in this case is just a segment, using, for example, Sobel sample, which is a sampling techniques already implemented in Surrogates. Okay, what if I want to have a sampling technique in two-dimensional, as shown in the figure on the left? Well, nothing easier in Surrogates. You can just define your LB UB as a vector, as arrays. So lower bounds again and upper bounds. So we have on the first dimension is between 0 and 2.5, and the second dimension is between 1.0 and 4.5. And here in this case, I want 100 points. And I can just call this like a sample 100, lower bound, upper bound, and again, for example, Sobel sample. There are many sampling techniques already implemented in Surrogates. Okay, then now we have our points. We want to model our expensive black box function. So what we do? In this case, for showcasing purposes, I've already defined the function f that we want to approximate. Now, it's never the case that you actually already know the analytical form of your function. But just for example, this is more than enough. So I define my function. You see the syntax sugar in Julia is really nice coming from a mathematical perspective. F is just a mapping between x and the function that we want to define, exponential times plus blah, blah, blah. We define our lower bound and upper bound, and we sample, again, as shown in the example before. And then we call our function f on the x vector, and it is our y. So we now have data points, x and y. And we, for example, we can call our Kriging method, which is a surrogate modeling example. Kriging is a Gaussian process in one dimension, if you're familiar with Gaussian process. And then when I call Kriging of x, y, and p, which is an hyperparameter, and we save this call on my Krig, then we have our Kriging model. And we can already use that. So if I want to say, okay, what's the value at 5.4 of my function f, then I can just call my Krig of 5.4. And this is our approximation. Now, I choose Kriging as an example because it has the interesting property that the Kriging model also knows the standard error at the point. So it's actually a probabilistic modeling approach. And so I can find the standard error of the Kriging at that point, which I found pretty cool. Okay. Another example, we can call the Lobachevsky surrogate, which is another neat approximation technique that resembles radial basis functions. It's actually a limit of radial basis functions. I choose this example again because you can calculate approximate the integral of your surrogate model, that is the Lobachevsky integral, with a closed form solution. And here we compare the approximation done with the closed form solution, calling Lobachevsky integral of my Loba a, b, where a and b are the lower and upper bound of the integral, with the approximation by quad jk, which is a approximation integral library in Julia. And then we showcase that the error is less than 10 to the power of -5, which is pretty good. Okay, moving on. We now have our modeling object, but we are also interested in optimizing this object. So when we say optimizing in general, we are just looking for the minimum, right? As I said at the beginning. However, given that we are in the surrogate modeling domain, we are not only interested in finding the minimum, but we are also interested in smart sampling while we are finding the minimum. So this is like an exploitation versus exploration trade-off. What does it mean? Exploration means we want to sample in regions where we are not sure about the solution. Exploitation means finding the minimum. And so there is this balance. Do I look for the minimum now with the sample points that I already have? Or I want to explore a little bit my space, sample a little more around areas where I don't know much about our model, and then find the minimum? So this is why I think optimization techniques for surrogates in general are pretty interesting. And there are many, like 5 or 6 different optimization methods that you can choose from. Okay, and here it's showcased an example. Here we have it's actually in a 3-dimensional example. We have our objective function, which is pretty simple. It's just the norm times 3 plus 1. And then we want to optimize our cryogene surrogate. This again, we define our cryogene with x, y, our points, and some hyperparameters p and theta. And then what do? We do surrogate optimize, and we pass the objective function. That's the goal, the computational heavy function that we want to approximate. We pass the method, the optimization method, which is in case is EI, that stands for expected improvement, which is a pretty common optimization techniques for Gaussian processes. Then we pass lower bound and upper bound again, because we will need to tell him to look for points in this region. We pass it also the surrogate model that we defined before, and a sampling technique for sampling during the optimization. Okay, let's now talk about something different. Usually, we are not only interested in having only the approximation of the surrogate of the expecting function. We want also to have the derivative of the function f. There are a few problems though. The first problem is that we could use symbolic derivation, but it's often too slow, so it's not a great solution. Usually, to approximate a derivative, we can just use the finite difference method, which can be done in practice, and it's most usually the way it is, but it can have some numerical issues, numerical cancellation, probably, and it's not very precise if you don't choose the right hyperparameter. But there exists a third way, which is automatic differentiation, which is more precise and computationally faster. And Julia has many different tools for automatic differentiation. Now, where does surrogate comes to play with this automatic differentiation thing? Well, we can actually define, as shown in this example, we can define our surrogate model, in this case, a neural network, using Flux, which is, say, the equivalent of TensorFlow and PyTorch in Julia. So we define this neural network called the neural surrogate in surrogates. And then we can, after that, we can define G. And this function G here is just, as you can see here, the derivative of our surrogate model. So it is the derivative of a neural network, whatever that means. We don't care about that. We are just trying to approximate the derivative of the function f. So to sum things up, we have f, computational expensive. We approximate it with a surrogate model, in this case, neural surrogate and neural networks. Then we define G as the derivative of the surrogate. That means that as a second order approximation, we actually G is the approximation of the derivative of f. And I find this pretty interesting and pretty useful, because as I said in the slide before, derivatives are used in many optimization processes. Great. So paper. Here the date is September 2019, which is the date where I ended my Julia Season of Contribution project. So 2 summers ago now. The paper has not yet been published, but I guess I'm working on it. But this is just to showcase that it's not about coding, not only about coding. If you're interested in more, say, research space, research avenue, then it could be also interesting for you to apply to these kind of things. And especially, I can speak about the Julia community here. There are many professors at American universities or European universities that are engaged in the community. And usually it's very easy to speak with them and share a little talk and chat and understand if there are some possibilities for you to work with them. This is what I did for the Alan Turing Institute, for example. I just found the job ad on the Slack channel in Julia, and I've talked a little with the professor, and we decided to go on from there. So this is just to showcase that there are some research possibilities in Julia, given that it's quite early stage and it's widely used in universities. Okay, then of course now by near the end of the talk, say, of the slides, you of course you want to join the Julia community, and that's great. I guess I hope. So how exactly does it work? What I suggest doing is, first of all, you need to understand what you're interested in. That's the first step. And after, you could take a look at this website here, Julia Lang JSOC projects, and there are listed many projects spanning a diverse set of problems, from machine learning to compiler to mathematical projects. So there are a lot of things that you could possibly be working on. So you pick your project, you look at the library, you understand what actually you need to do, and then the best course of action is to actually go on the Slack, on the Julia Slack, present yourself, and speak with the person or with the people that are working on the project, and try to showcase what you can do. It's best if you come prepared. I mean, do your homework, and as in look throughoutly to look at the GitHub source code, look at the common issues, maybe introduce yourself, suggesting what you could be possibly working on as a starting point to showcase that you are actually, that you actually know what to do. And so here there are some different projects, as in scientific machine learning, which is a combination of differential equation solvers with common machine learning techniques like neural networks. And this is there are many papers around now called under the line of universal differential equations. And I find this topic pretty interesting. And Surrogate is under the scientific machine learning umbrella as a gap bridging between, say, differential equation solvers and machine learning. Then, of course, there are more standard topics in machine learning, like computer vision, reinforcement learning, agent-based model, natural language processing, which are usually done in Flux here, which is this library that, as I said before, is a neural network library similar to PyTorch, I would say, if you come from a Python background. And then there is the MLJ toolbox. It's a very strong and big library that I think if we want to make a simplistic comparison, it could be similar to scikit-learn for Python, but I think it's much more than that. And I've worked on MLJ with the Alan Turing Institute, and I can strongly encourage you to apply there because there are many very kind people that are always happy to have new students help, and they are very good advisors. And then, of course, there is not only machine learning in the world. There are different topics. There are compilers, high-performance computing, parallel computing, numerical projects, and graphics, and many more. I will not talk about this kind of projects because it's not my area of expertise. What I want to say, though, is that Julia sponsors not only Google Summer of Code, that is, not only Julia participate in Google Summer of Code, sponsored by Google, but Julia is also sponsoring with its own money the Julia Season of Contribution. This is the first thing I've done, as I said here, JSOC. So for people that do not get accepted to the Google Summer of Code, because mainly there are too many, there are not so many places for the Google Summer of Code, then Julia sponsored the Julia Season of Contribution. I think it's a very generous activity. You are paid a bit less, I believe, but I don't think that what drives you in the open source community is pay. And I think it's still a great way to get involved in the community I've done it myself. I've started in one summer with the Julia season of contribution, and then I've moved to Google Summer of Code the summer later. What I want to say, closing in, is that I'm actually thinking that I could be mentoring for the upcoming Google Summer of Code. So if someone is interested in working in surrogates models, then you can contact me on, say, LinkedIn, if you want to connect with me on LinkedIn, or I would prefer that you write me on Slack. Actually, I'm usually online there, so we can chat a little bit, and you can apply. Of course, I cannot say for sure that you will get in, but if you write up a strong proposal and you showcase that you know your way around the scientific machine learning community, then it's a good shot. And of course, I will not be the only mentors. Probably Chris Rakaukas will be mentoring, as he is mentoring a lot of people. So I think it's a great opportunity if you're interested in what I've talked before on surrogates. And if you have any questions, you can write me in a chat personally, or you can ask them here now. I think that we have a question and answering section now. So thanks for being here, and I look forward to the questions.
Yeah, so right now we have some setup questions.
Okay.
We have a question from Rishika Raj. She is asking like how competitive is the Julia community for GSOC?
Yeah, usually I have to say it's quite competitive. I think Julia is gaining a lot of traction, and many people are interested in that. So having said that, that should not discourage you from applying. You can apply to up to 3 projects, I believe. So you can apply to Julia and to other, say, safer projects, if you may. However, I suggest also not to apply to too many things, like choose the project carefully, because in the end, you could be applying to 3 different projects and not get into any of them because you stretch yourself too thin. Instead, what you could do, you could focus on one, maximum 2 projects, and you really need to pour your heart into it and really have a strong proposal. So yes, to answer the question, it is competitive, but that should not discourage. And also it depends on which topic. Like scientific machine learning is very hot at the moment, and machine learning in general. Maybe other not so glamorous projects could be less competitive.
Yeah, I have a personal question for scientific machine learning organization. Should a beginner or a second year undergraduate student apply for scientific machine learning organization for GSOC?
Okay, sorry, what's the question?
Like if a student is in the second year of his undergraduate course, then should he apply for SCIML organization or should he look for any other organization?
So I don't think that being in your second year is a problem. I think you should have some strong knowledge of machine learning in general and differential equations. However, it's not required that you have to have passed some courses or something like that. You just need to have the knowledge that you can get yourself by reading some books and topics online, and you can learn before applying. So I think the deadline for applying is still 2 months away. So if you start now and you contact the right people, there is plenty of chances that you can, if you invest the time, you can get up to speed with the work that you need to do, which is usually very specific. So you don't need to know everything about scientific machine learning, just a tiny little bit, which will be what you are going to use on the project.
Okay. So Mr. Mayuk Pankaj is asking any tips for the GSOC proposal?
Yes, this is a common question. I've done my proposal in LaTeX, which I think it's pretty useful if you need to write some mathematical operations. But apart from that, which might be a bit too easy of an answer, what you need to showcase in your proposal is that you know, I mean, you can hit the ground running So you start the project and you know what you need to do and you can do it. So to showcase that, it's important not to write too much with something that is not interesting. You should have a section which is the strongest section in your proposal, which lists all the pull requests with links that you have merged in your project. So, and if you don't showcase any code whatsoever, it's usually impossible to get into the Google Summer of Code or Julia Season of Contribution. You should have, at best, many pull requests reviewed by community members that, in this case, showcase that you know how to write code. If you can't do that, at least you should have some code that will be the starting point for your project. In my case, for example, when I applied 2 years ago and I got accepted for the Julia Seasonal Contribution, I did not have any pull requests, so that was bad. But I did have some examples of surrogate modeling techniques that I could use, and there was some code lying around of definitions of functions and whatnot, and sampling and optimization techniques. So I already did have something to start off. So that's very important.
Yeah, I have another question from my side. How many participants selected for the GSOC in the Julia community?
This is a hard question. I don't have exact numbers. I believe that around 15 to 20 students are selected for the Google Summer of Code, but on top of that, you need to sum all the others that are selected for the Julia Season of Contribution, which is, at the end of the day, the same exact work. So you should not feel sad about being selected there. So in total, approximately 40, I would say, combining both GSOC and JSOC.
Yeah, so we have a question from Kanak. He is asking, what is the benefit to be a contributor in open source communities?
Yeah, this I like this question a lot. So if you read, there are many benefits, I believe. First of all, you work remotely for a big team, diverse community, and you learn to interact with many people from around the world, which is I find this very, very interesting. And this showcase to future employers that you know how to work well in a team. So that's the first point. Secondly, usually it's not very industrial focused. It's more research focused. And so if you want to apply to later on to some masters or some PhDs, and you want to showcase your research ability, it's usually a great way to do this, because I mean, for the Julia community, it is usually the case.
So like the open source contributions helps a lot in our MS and PhD application process.
Yeah,
and
because
also we
because
get an opportunity to to connect with the foreign professors and foreign PhD students and foreign postdoctoral students who work in these fields.
Yeah, exactly. And probably you can also, if you have if you are more strong-willed than me, you can also write a paper, which I have the opportunity to do, but I couldn't get around doing it because of lack of time. But you can also do that, which is very, if you want to apply to PhDs, it's usually very important to have already some papers out.
So we have another question from Kanak. He is asking, what will be projects being taken under GSOC or Julia Summer of Code other than the libraries?
Also, it's not usually the case that you write a library starting from zero yourself, which is what I did with Surrogates. But say if I now wanted to contribute to Surrogates, you will be just improving on existing methods that are already there, or defining new optimization techniques, sampling techniques, or modeling techniques to add to the library. In one way or the other, you contribute to a library. If you are more into, say, web development, there are also some opportunities as well there. It's not my field, so I cannot speak too much about that, but it's possible also to do that.
Yeah. So we have another question. When several of students are trying to see the code base and issues, they didn't get any idea how to go to solve the issue and how to go through the code. Do you have any suggestion?
Yeah, this is usually, good question. This is usually one of the main problems that students have, and they get discouraged quickly because they can't get their heads around a code base. Now, I have to say in Julia, this is still an issue, but not a big problem per se, because you need to understand that the Julia libraries are very small. Say, you want to have PCA, Principal Component Analysis in Julia, there is a specific library that does just that. You want region lasso regression? There is not a big scikit-learn library. There is just the ridge.jl and lasso.jl libraries that do just that. So it's very narrow focused, and it's easier to navigate around the code base. Still, it's not something that it's easy to do. And if you get stuck, you can usually ask around. It's not a big deal. You don't have to ask too many questions without doing your homework. You need to sit down, learn the code carefully, and have very precise questions. But if you do, a lot of people will answer you for sure.
Yeah, right. We have a question from Atulya Singh. What are the requisites to build a strong team to build something novel like Julia? What be the different idea and target market more like a business enterprise? She wants to be
Oh,
an
wow.
entrepreneur.
Yeah, very hard question for me to answer. So, requisite to build a strong team, to be something novel like Julia. But I have some follow-up questions myself. Like, do you want to write another programming language that solves a different issues, like a domain-specific language, or you are actually asking about building a startup in general? Because if you are asking about building a startup, I'm not the right person to answer that question, and you shouldn't be asking me the question. If you want to write a different programming language, it's usually an gigantic tasks that's done by researching in compilers and programming languages. So you should be having a strong team of people that are expert at building programming languages, and you should have a clear and exact idea on what you will be doing. So clear idea and strong people that know what they're doing. But it's very general answer. I know. I don't have more details than that.
Yeah. We have a question from Kajal. How do you plan to develop more surrogates methods?
Oh, thanks for the question on surrogates. This is usually very easy because there are many papers and many libraries around in other languages that do surrogate modeling, like Python. So the first easy idea is to check out other libraries, see what surrogate methods they have, which we don't have, and look for the references to those papers and implement the models ourselves in Julia. This is the easiest thing to do. I never come up with surrogate models myself. I just read papers and implement what I see in the papers. Or secondly, we could, maybe an easier thing will be improving on already existing surrogate models that we have in the surrogates.jl library. This is also, there is plenty to do because of course I left some bugs around the code, of course, and who doesn't? And then there are some things that should be fixed, and there is actually a long list of issues on the GitHub page, which I couldn't get around fixing because of limited time, but with the help of some people, we can start working on them.
We have a very simple and easy question. Why one should learn Julia?
Well, okay. Why one should learn Julia? Probably this question comes from the idea that there is already Python that does something similar, and why would I need to learn Julia? Well, if you want to, right now, if you are about to graduate and you're looking for a full-time job in software development, it's not probably a good idea to learn Julia because industries at the moment are not heavily using Julia. There are some niche markets like pharmacological quantitative
Yeah,
pharmacology.
pharmaceuticals.
Yeah, that they really use Julia a lot. They employ Julia a lot with scientific machine learning, say. And I mean, there are some companies like also a Canadian
Like
company.
mostly, if you want to involve yourself in academic or scientific research, then I think
Yeah,
you should opt Julia, I guess.
yeah,
And
yeah,
if you are targeting development job, then I think you should not go for Julia. You should choose more popular languages like Python, Java, and C++.
yeah. But I think Julia is always nice to learn because I mean the slogan is feels like Python, runs like C, which is
Yeah.
kind of true. So that's, I think you should take a look and see if you like it without judging. Like you should judge by yourself if you like the development flow and what you can do with it. Yeah,
We have a question. Is there some plans to convert the tutorials available in the website to Jupyter notebooks so they can be more interactive and easy to follow?
great question. Of course, we should do that. Why not? I'm waiting for a pull request at Kanak now about this idea. So yeah, of course, if you have open an issue on GitHub Surrogates and let's discuss it, and we can of course have it. Why not? I don't see a reason why we shouldn't. Great idea. It's a great starting point
Uh,
because you add something and you learn a bit about how the library works, as I said, and then we can start diving in deeper into that. Perfect.
yeah, like he can start this discussion in the Julius Slack channel as well.
Yeah.
Hmm. So, okay, we have not any other question right now.
Perfect.
And guys, if you have any other question, then you can like contact Mr. Ludovico in the Julius Slack channel as well. And
Sure.
if you have any questions related to surrogate, then I think there is a workspace named SCIML right now.
Yeah. SCML or DFAQ bridged, whichever,
Yeah,
or you can write me personally if you prefer.
yeah. We have a question from Mr. Sivasis Fadi. Are Google Colab notebooks good to practice Julia on rudimentary levels?
Well, I myself usually use like a simple Jupyter notebooks on my desktop, say, but I don't see why not. It's up to you, the development workflow.
Yeah, because
No,
maybe in Google Colab we will have to install a Julia library again and again, and in the Jupyter Notebook, if we install a library once, then I think we can call that library anytime. I think it is
yeah,
the main benefit of Jupyter Notebook
yeah, I agree.
or any local environment like VS Code or Atom if you use. Okay, so thank you so much, Mr. Ludovico, for enlightening us with your knowledge. And you have created a new spark in our data science summit, and many people have known about that how he can or how she can participate in the Google Summer of Code inside the Julia community. And we certainly want to stay more like what we understand like. Right now, we have not any other question, and if the participants will have any questions related to Google Summer of Code, then I think he or she can reach out to you on LinkedIn or as well on Google Slack as well. So let's
Sure.
conclude today's session. And so bye bye everyone, and thank you so
Yeah.
much.
Thanks a lot. Bye.
Yeah, bye. Take care.
Thank you so